So far, we have deeply understood about F test and how to perform this and regarding the ecosystem of F test. But now it's time to apply the F test. So to apply the F test, we should know what all types of F tests we have. So we will understand this F tests with respect to the data science perspective, not a statistician perspective. So I always tell my data scientists, my fellow data scientists who works under me, if you know the F test, if you know how to perform the F test, you had a fantastic tool in your data science toolset because it's gonna help you in a lot of things. It's gonna make your life much easier. Either uh, it could be for feature selection, or it could be for check the statistical significance of your overall regression model. So that's the reason I say this is a fantastic tool to be have in your armor. So primarily there are two types of F tests. These two types of F tests are commonly used in, of course, statistical analysis, experimental design, and mainly regression modeling. So we'll begin with the first one, the one-way F test. That's the first one, the one-way F test. So one-way F test is a statistical test used to compare the means of two or more groups or treatments. It assess it assesses whether there are significant differences among the group means. So let's get into the detailed explanation of one-way ANOVA test. So first let's define what is ANOVA one-way test. So one-way ANOVA F test is used when you have a categorical independent variable, also we call it as a feature or predictor, with two or more levels. That may be that categorical variable might consist of three categories in it, four categories in it, or five categories in it. It doesn't matter. It could be how big is it could be multinomial. Okay. So and a continuous dependent variable, also called as a target variable, response variable, outcome or output. So now a one-way F test is used when you have a categorical feature and a continuous target variable. So this can be used. So these kind of situations we will be encountered a lot of times. So that's the reason this is the fantastic tool to be had in your toolset. So it evaluates whether the means of the dependent variable differ significantly across the different levels of the independent variable. Now let's look into the applicability. One way ANOVA F test is applicable to data that involve multiple samples or groups. It compares the variability between the group means to the variability within the groups to determine if there are statistically significant differences among the groups. So now let's look into the formula. The F statistic is one-way ANOVA. The F statistic in one-way ANOVA is calculated as the ratio of the between group variability to the within group variability. So the formula for F statistic is here. So it's mean squares between divided by mean squares within. So what's mean square between? So So mean square between is sum of squares between divided by degrees of freedom between, and we have the mean square within is equal to sum of squares within divided by degrees of freedom within. So degrees of freedom between is equals to k minus 1, and degrees of freedom within is equal to n minus k. So what is k? K is number of categories or groups that a variable, that categorical variable consists of, and n is total number of observations or the total sample size. How big is that total number of observations in that variable, or total sample size, whatever way you can tell. Okay, so that's how we calculate the F statistic in one way ANOVA F test. So now let's look into the some of the real-time machine learning feature selection examples. So one way one way ANOVA F test can be used in feature selection in machine learning when dealing with categorical independent variables and continuous dependent variables. So here are a few examples. First one, let's look into the e-commerce website. So let's take our independent variable. Product categories is the independent variable. So example, this consists of three categories inside it. One is electronics, second one is clothing, and third one is books, and that's what is our independent variable. So now let's take a dependent variable as a purchase amount, a pure continuous variable. Now ANOVA can be used to determine if there are a significant differences in purchase amounts across different product categories, helping identify the most influential product categories for predicting purchase behavior. This is one example. And similarly, we have a sentiment analysis. Let's take a sentiment analysis. So in sentiment analysis, independent variable could be a different sentiment analysis algorithms, and dependent variable would be accuracy or sentiment classification. So ANOVA can be applied to assess if there are significant differences in classification accuracy across different algorithms, aiding in selecting the most effective algorithm for sentiment analysis tasks. And one more is customer satisfaction, the most important application. So let's take an independent variable as service levels and a categorical variable. Example, service levels are good, average, or poor. Now the dependent variable is whether it's a customer satisfaction scores. That's what is our dependent variable. So ANOVA can be used to evaluate if there are a significant differences in satisfaction scores among different service levels, guiding the identification of the most impactful service level on customer satisfaction. So these examples demonstrate how one-way ANOVA F test can be used in feature selection to determine the statistical significance of different categorical features on a continuous target variable in various real-life machine learning scenarios. So now let's get into the second type of F test, which is regression F test. So regression F test is applicable when you have a regression F test is applicable when you have a continuous dependent variable and a multiple independent variables, or we call it as a predictors. Okay, let's get into that later, but let's see we let's see regression F test. We also call regression F test as overall F test. Okay, so it's a statistical test used in regression analysis to assess the overall significance of a regression model with multiple predictors. So it determines whether the model with multiple predictors is a significant improvement over an intercept only model. So let's have an explanation of regression F test along with some examples. So let's define the regression F test first. So A regression F test is applicable when we have a continuous dependent variable, which is our target variable, and a multiple independent variable, not one, a multiple independent variables, which are categorical variables, which are predictors. Basically, it evaluates whether the combination of predictors has a significant effect on the dependent variable, and if the regression model as a whole provides a better fit than a model with no predictors. So now let's look into the applicability of a regression F test. Regression F test is applicable to data that involve multiple predictors and a continuous dependent variable. So it's used to determine if the overall regression model is statistically significant, indicating whether the predictors collectively contribute to explaining the variability in the dependent variable. Then let's look into the formula now. So we have seen the formula of one-way ANOVA F test. So how would regression F test formula look like? You might have that excitement to see. Yes, I too. So the F statistic in regression F test is calculated by comparing the variability explained by the regression model. We call it as explained sum of squares to the residual variability. So residual sum of squares. So the formula for the F statistic is equal to explained sum of squares divided by P, and the whole thing will be divided by residual sum of squares divided by n minus P minus 1, and where explained sum of squares is nothing but measures the variability explained by the regression model, and a residual sum of squares is nothing but it measures the remaining unexplained variability after accounting for the regression model, and the P is nothing but number of predictors. Of course, number of predictors are your independent variables, and we have n. This is total sample size. So now let's look into some of the examples. Okay, so regression real life ML examples where this regression F test can be applicable. So regression F test is commonly used in machine learning for feature selection and model evaluation. So here are a few real life ML examples. So the first one will begin with the house price prediction. So when it comes to the house price prediction, let's take our dependent variable first. Dependent variable or target variable is sale price of a house. That's a continuous variable, quote unquote. Quote unquote, it's that. Then we have independent variables. Okay, let's take some of the independent variables here: number of bedrooms, square footage, location, age of the house, number of bathrooms, etc., etc. Okay, so these are my target variable and these are my predictors. My target variable is sale price, which is a continuous variable, and I have a features which are continuous and which are numerical and categorical too. So now if I use a regression test, the regression F test can be used to assess the overall significance of the regression model, indicating if the combination of independent variables has a significant impact on the sale price. So next, another example that we can cover up here is customer churn prediction. So here in customer churn, dependent variable is obviously churn status, whether churned or active. Independent variables, customer demographics, usage patterns, customer service interactions, and subscription details, etc. Most of them are categorical. So now to use the regression F test, if I apply a regression F test, so what I can get it. So by applying a regression F test, you can evaluate if the regression model with multiple predictors is a significant improvement over a model with no predictors, indicating the collective significance of the independent variables in predicting customer churn. So one more example that I have with me is credit risk assessment. So a dependent variable here in credit risk assessment is credit risk, example low risk or high risk. Independent variables, credit score, income, debt to income ratio, loan amount, etc. So regression F test can help determine the overall significance of the regression model in assessing credit risk, indicating if the combination of predictors collectively contributes to predicting credit risk. So these examples illustrates how regression F test is used in machine learning to evaluate the overall significance of the regression model with multiple predictors in various real life scenarios. So that's the reason knowing these two F tests, one way ANOVA F test and regression F test, you will become a better data scientist in handling most of the machine learning problems.